is for the specific IC MC9S12DG256 we will use in the lab. So this is the diagram of the micro C, HCS12. And where is the memory? So this is our memory, and where is our CPU? Here is our CPU 12. And the rest are for the I/O ports. So we have port A, port B, port M, port K, port J, port S, H, T, E, and analog to digital. Okay, this is pin assignment. So every port we have the pin. So for the this IC consists of 112 pins. So we can see here where is port A. So port A, we have port A0, 1, 2, 3, 4, 5, 7, 6, 7 here. This is for port A, and other we can see with this diagram. Okay, this is CPU register. CPU register inside the CPU. So we have to know in details. We have register A, register B, or register D. Other name is accumulator A, accumulator B, double accumulator D. And then we have index register X, index register Y, SP step pointer, PC program counter, and this one is CCR, condition code register. Okay, and then we have to know the size of each register. So for accumulator A and B, only 8 bit. Here is 8 bit and another is 8 bit. And then D is concatenate from A and B and become 16 bits. X, Y, SP and PC same size, 16 bit. And the last one is CCR, only 8 bit, and each bit consists of condition code register. So for bit 0, it has C, represent carry, V overflow, Z 0, and so on. So this is the prefix for number bases we will use in the programming. So if we use the binary number, so we have to put the percent before the value. And if you use octal, we have to use alias. And decimal, no need to put nothing. And hexadecimal represent dollar represent hexadecimal. So this symbol will represent different value of number. Sabira model. Okay, this is the data inside the HCS12. So either we can use bits, binary number, or we can use 5-bit signed integers, 8-bit signed and unsigned integers, 8-bit 2-digit by BCD, 9-bit signed integers, 16-bit signed and unsigned, 16-bit effective addresses, and 32-bit signed and unsigned integers. So this example of the data you already look in chapter 1. Okay, now we go to the assembly program structure. Actually, assembly program structure is easier than I think than C or other, because the structure is fixed. Okay, we have 4 columns for the programming. We have 1, 2, 3, and another one. Okay, for the first column is for the label, and the second column is for the operation field, and the third column is for operand, and the last column is for command. So every programming in assembly language, we will follow this structure. Label is and command are optional, but label is compulsory. Even label is optional, but the structure is compulsory. Label here. Let's say you don't put the label, but you have to put the space. Okay, example, we have origin 800. And then you don't want to put the begin. You just start with LDAA H10. And then the next instruction JSR hex out. So you don't put the label here and you don't put the comment. It is optional, but label is compulsory. You have to space. You have to put the space. But the comment you can if you don't want to write, so you don't put anything. Okay, so what is a label? Label are symbol defined by user to identify memory locations in the programs and data areas of the assembly module. So for example, we have origin 800. So our instruction is start with 800. So the label here, let's say we write begin here. It represents the first instruction start with 800. Okay, here. So means the instruction LDAA, it will store inside 800. 800 inside the memory. Okay. So either you want to write or not, up to you. But you have to put the space. Okay, and then next. Next we have operation field. Okay, operation field specifies an assembler instruction. So every instruction you can look at the appendix A. Okay, so you can look at appendix A. We have I think more than 1,000 instructions. So you can write. Okay, just refer to the appendix A. And the next field. Next field is operand field. The operand field is present, it follows the operation field and is separated from the operation field by at least one space. At least one space. It must be followed with the operation field. Okay, it means it will operand will complete the operation field. Okay, for example, LDAA means you want to insert the data into the accumulator A. But what is the data? So what is the data is actually the operand. The operand, yes. It will complete the operation. Okay, and comment. So let's say comment, it's up to you. You want to write the meaning of the instruction. So I put